Yeah, Assalamualaikum and good afternoon. Okay, we are going to learn today topic heat. The first topic is thermal equilibrium. Okay, so what are you going to learn in this topic? First, we are going to explain with example thermal equilibrium in daily lives. The first thing you have to know what is the meaning of thermal equilibrium. Okay, so look at this picture, a cup of coffee. So when a cool metal spoon is put into a cup of hot coffee, the spoon and the coffee are said to be in thermal contact. Right? So heat energy can be transferred between the two bodies. How can the metal spoon cool down the hot coffee? And what is the final condition of the spoon and the coffee? Okay, let's look at these two pictures. Okay, first a boy feels the heat of the kettle. Why? Second, the ice melts when it is in the boy's hand. The boy's hand is cool. Why? Okay, so let's answer the question. Okay, the first one, the boy takes his hand away from the kettle because the boy feels the heat of the kettle. The heat is transferred from the kettle to the boy's hand because the kettle is hot and the boy's hand is cooler than the kettle. Right? So, heat is transferred from hot object to cool object. Okay. Secondly, the ice melt when it is in the boy's hand. The boy's hand is cool because heat is transferred from the boy's hand to the ice, and heat is transferred from hot object to cool object. So again, heat is transferred from hot to cool object. Now, what is the meaning of heat? So heat is a form of energy. Remember, we have so many types of energy. So heat is one type of energy that we have. Okay, what is temperature? So temperature is the degree of hotness. Okay, so when you feel 6, your temperature will become higher than 37 degrees Celsius. Right. So SI unit for temperature is Kelvin. Normally we use degrees Celsius, right? But for SI unit for temperature, we use the unit of Kelvin. So we will learn this later on. Okay, so now we compare between temperature and heat. Okay, the first one, definition. Temperature is degree of hotness, while heat is a form of energy. SI unit for temperature is Kelvin, and SI unit for heat is Joule. Now, measuring device for temperature, of course, thermometer, and heat we use what we call calorimeter. Temperature is a base unit ataupun base quantity, while heat is a derived quantity. Now, when an object is heated, so heat absorbed and temperature increases. When an object is cool, okay, heat releases and the temperature will decrease. Okay, these are example: hot object, cool object. Now, so we are going to learn the meaning of thermal equilibrium. So we have first activity to show thermal equilibrium between two bodies in thermal context. So the apparatus, we did 2 retorts stand, 2 thermometers, 250 ml beaker A and B, measuring cylinder, stopwatch, hot water, tap water and tissue paper. Number 1, wrap beaker A with tissue and fill it with 100 ml of tap water. Number 2, fill 40 ml of 50 degrees Celsius of hot water into beaker B. Place beaker B into beaker A, then place thermometer A and thermometer B into beaker A and beaker B respectively. Then record the readings of thermometer A and thermometer B every 30 seconds until the readings of both thermometer are the same. So here we have beaker A, bigger beaker A, and then we put tap water, and then we have a smaller beaker filled with hot water at 50 degrees Celsius. Then we put it inside the beaker A. Then we take the temperature for the two thermometer. Okay, so this is the result. So thermometer A increasing, thermometer B decreasing until they both have the same temperature. So first question, why is beaker A wrapped with tissue paper? To prevent heat absorbed from surroundings. Second question, describe the changes in temperature of the hot water and tap water. So as we see, so when the two water are in thermal contact, the temperature of the hot water decrease while the temperature of the tap water increase until both objects have the same temperature. Now what caused the changes in temperature? So hot water release heat to tap water absorb heat from hot water. Transfer of heat occurs when the two bodies are in thermal contact. Okay. Alright, so we have this diagram, hot water in beaker in color red color and tap water in beaker A. So describe the transfer of heat between hot water. So heat is transferred from hot water in the beaker to the tap water in with high rate. So most of the heat are transferred from beaker B to beaker A. So heat is transferred from the tap water to the water in the beaker with low rate. Also, there will be heat transfer from tap water to the hot water but in a low rate. The direction of net heat transfer is from hot water in beaker B to tap water in beaker A. Remember, from hot object to cooler object. So temperature hot water decrease and heat release. Temperature of tap water increases and heat absorbed. Now compare the temperature of both thermometer after 5 minutes. So both have the same temperature. What happens to the rate of heat transfer after 5 minutes? The heat transfer at the same rate because the hot water in beaker B to tap water in beaker A. Because both heat transfer from B to A and also from A to B with the same rate. Okay, so as a conclusion, what can we say about the net rates of transfer of heat when the readings of the two thermometers become equals? Yeah, we said that there is no net heat transfer between both readings, no dominance. Both object transfer each heat. So we said that the net rates of heat transfer is 0. Means that both hot water and tap water are in the state of thermal equilibrium. So what is the meaning of thermal equilibrium? Thermal equilibrium means so there is no net flow of heat between two subjects. Two objects have the same final temperature. Okay. Right. A hotter than B. So heat, majority of heat transfer from A to B. Only a minor of heat transfer from B to A. But after thermal equilibrium is reached, both have the same temperature. Let's say 50 degrees Celsius means that heat is transferred both from A to B and also from B to A at equal rates. Okay, so the net heat transfer between A and B becomes 0. Okay, so let's look at example in our daily life. So we have the first one, a wet towel is placed on the forehead of a person who has a high fever. Okay, so what we have here is initially the temperature of the cloth is lower than the body temperature of a person, right? So heat energy is transferred from the forehead, which is hotter, to the towel until thermal equilibrium is reached. As a result, the heat energy is removed from the person. So the towel is rinsed in the tap water and the procedure is repeated, right? Okay. Second, cooling drinks. Okay, first we have to put ice into the drink. So hot drink can be cooled by adding a few ice cubes to the drink. Heat from the hot drink is transferred to the cooler ice until thermal equilibrium between the ice and water is replaced. The temperature of the drink decreases and the drink cools and the ice also melts. Okay. Okay. So next, cooling object in refrigerator. So when food is kept in the refrigerator, heat from the food flows to the air in the refrigerator until thermal equilibrium occurs. Temperature of the food drops and the food stays fresh for a longer period. Okay. Now in this case, the food gives heat to the air and the food lost heat, so it becomes cooler and stay fresh. Now the fourth one is the baking cake in oven. So this time we need the heat. So what we have there is hot air in oven is in thermal contact with cake batter, right? The heat from the hot air flows to the cake batter, right? And this causes the cake batter to be heated until it is baked. Okay. And the last one, taking temperature of a sick patient. First, a clinical thermometer is placed under the tongue of a patient. Heat from the patient's body flows to the thermometer until thermal equilibrium occurs. And the temperature of the patient and the thermometer become the same. So the body temperature of the patient can be determined because the body temperature equals to the temperature of the thermometer. Alright, so we continue with the next topic next time. So we stop here. Okay, so that's it for the first lesson. Thank you.